Okay, good morning, everyone. So today I'm just going to be giving you a very brief outline over some of the geophysical data sets that we have available in Victoria relative to gold exploration and some of the techniques we can apply to enhance the value of those data sets, and then briefly talk about how we apply them to our interpretations. So just a brief outline of the talk. So to start off with, I guess we're really lucky in Victoria because we've got a great history of geological mapping in the state, spanning back over 150 years. And most recently, we've come up with some great seamless geology products, so 1 to 250 and the 1 to 50K seamless geology maps. And they're great for interpreting the Paleozoic bedrock. So the blue and purple sort of rocks through the centre of Victoria there. And these rocks are typically the ones that are associated with historical gold exploration and occurrences. Everyone knows about the Golden Triangle in central Victoria there, where most of the gold has come from. And so I guess the current focus of exploration in the state is to expand that search space, and going north under the Murray Basin cover is one of the great options to be able to do that. So the Murray Basin is a younger set of sediments that cover the Paleozoic rocks in the northern parts of the state, and we've done some work to try to help understand that basin. So a depth to basement surface is available for download and for use, and that contains various units within the basin derived from drill hole intersections and geophysical modelling as well. We've also got great regional airborne magnetics coverage. So here you can see all the different types of surveys that have been acquired and then merged together into a statewide grid. You can see there, it's a 50 by 50 metre grid cell size covering the whole state. So again, a great resource when looking for exploration targets and to help your exploration, particularly in areas under cover. And that's all freely available from GADS, as is the gravity database and data sets. So nominal 1.5 kilometre spacing over the whole state, which is a really good coverage for a regional data set of ground gravity. And in places that spacing is much more detailed, anywhere down to sort of 100 and even 50 metres spacing. And again, a statewide grid is available, 300 by 300 metre grid cell size, available from GADS. We also have a full crustal transect, east-west transect across the state that gives us great information about the third dimension. So with depth, we can correlate the seismic interpretations with the surface mapping and surface outcrops. So again, been really great in trying to understand the evolution of the state and the geology. And a way that we can link the geophysics to the geology is petrophysics. Really important when we're doing our interpretations and modelling. And again, we have a fairly good database of around 250,000 rock property measurements, not evenly spread over the state, but gives you some really good insight into the response that you see in the geophysics and how that correlates with the geology. So looking at the Murray Basin, just before we do that, a quick kind of review of what you've heard already today. Orogenic gold systems in Victoria. We've got our source down in the lower crust, the thickened Morb volcanics. And then we have fluid pathways, the faults, the deep tapping faults that are conduits for the hydrothermal fluids that then provide and produce the mineralisation near the surface. So zooming into this area in the northern central Victoria region, we can see our mapping in the blues and purples with the major north-south trending structural faults and all the gold occurrences. And as you'd expect, they're limited by the outcrop of the Paleozoic basement. So stopping at the Murray pretty much, apart from a few. So how do we extend that interpretation and that knowledge undercover to the north? And you probably kind of can guess already, we can use geophysics, gravity in this case, to interpret those structures by tracing anomalies that we can correlate with the mapped geology in areas of outcrop, and trace those further north under cover. And similarly, we can do the same with magnetics. And looking at the seismic sections here, you can see some of the lines that we've acquired. If we just take these two, for example, there's the whole section covering the Bendigo and Stall zones. And zooming into this particular area here, we can see how we can trace those faults. So these deep crustal faults coming up to the surface where we have control, and where we can correlate them with anomalies we see in the potential field data, in this case, the gravity. And so we can trace those faults to the north undercover where we wouldn't be able to map them directly. So we have our potential field data sets, our standard data sets, and we can apply a whole bunch of different filters and enhancement techniques to those data to bring out some of the subtle features and some of the different sources of the response that we see. So for example, here we've got some filters that are showing up these higher frequency signals in the gravity data, and they correlate really well to some of the map faults that we see as well. Conversely, we can strip away some of that shallower response, so higher frequency response, and look at what's happening at depth in the sort of mid-crustal to lower crustal levels. And there's a whole bunch of different filters that we can apply to enhance these data sets. And we can do a similar thing with the magnetics. So you can see here, there's a TMI, a standard magnetic data set. And once we apply all these different types of filters, we're getting different sets of information about the geology and about what's happening in different levels of the crust from the magnetics as well. So not only can we look at those independently, but we can actually cross-correlate and combine some of these data sets to give us an even better understanding and more information about what's happening. So here, for example, we've got a high pass filtered gravity data set in the colors, and that's draped over a RTP intensity. So we're able to correlate the different data sets into one, I guess, one data set that we can utilize in our interpretations. And we can also do that with different filters, for example. So here's a tilt filter on the left and a bandpass filter on the right for magnetics in the Northern Bendigo zone. And if we combine those, we're kind of getting the best of both worlds in one image. So we've got these broader anomalies coming from deeper sources, and obviously shallow high frequency anomalies that are giving us information about the shallower sources. So in this case, all these dendritic paleo channels and some of the Heathcote volcanics responses that you see there. So how do we go about applying all these data sets and techniques to our interpretations? So I'll just run through a couple of examples. In the Northern Bendigo zone here, we've got our geology on the left with the interpreted faults and gold occurrences. Again, you can see they correlate and are associated with these deep crustal faults, these west dipping faults. And we can, if we overlay them on the gravity, we can interpret them and infer them from some of the response. So this is a 15-kilometer high pass gravity image. So if we strip away the cover, you can see these trends, these anomalies extending north under cover and really mapping out some of the faults that are interpreted in the outcropping areas. And if we overlay the major sort of prospects and mines, you can see again that they correlate really well with the anomalies and the interpreted faults. and in particular the Four Eagles and Tandara prospects, which are located beneath cover, beneath the Murray Basin. So gravity was a really useful tool for targeting that exploration and for being able to define those prospects. In particular, the Bendigo-Mediamo survey acquired in 2007, which was an infill survey, added a whole bunch more resolution to the data set, and was instrumental in that discovery. So looking at another example from Northern Bendigo zone, this is the Rochester antiformal stack. We've done some magnetic inversion modeling in this case, and here is the magnetic image, and you can see all these lines across sections where I've modeled and inverted the magnetic response. And what we see here is that in the south, as was mapped in the sort of outcrop regions in the south, we have these west dipping volcanic units, the Heathcote volcanics. And as we move north, there's a lot more complexity that comes out from the modeling. In fact, some of these units are dipping to the east and have been overturned. And if we look at that in 3D, we can see these bodies that have been modeled and inverted. And looking at them with the seismic section, you can see that they actually the geometries line up really well with what we interpreted from the seismic. And as you go north to this area of the antiformal stack, you can see that there's quite a bit of deformation of the west dipping volcanics. So what we're seeing is that at about 420 MA, this area was undergoing north-south compression, and that caused the buckling of the volcanics. So the volcanics thrust faults and the volcanic units, and that has led to these features like the Toobrack megakink in the south there that we can map, and what we see in the magnetics and the gravity, the antiformal stack further north. And from the modeling, we can see that the volcanics have been locally overturned in this region and buckled. So what does that mean about the turbidites? So if there's deformation within the volcanics, there had to be deformation of the turbidite pile as well. And in the south, we see that as a south dipping thrust fault. And presumably there would have to be a similar structure in the north there as well. And these structures trend, they line up along strike with Fosterville fairly well and into North Lockington. So perhaps this is telling us something about the localization of mineralization along the north-south primary structures. So having a look again at the modeling, you can see the overturned beds there where the antiformal stack sits. This is gravity overlaid on the top now. We can see some of these north-south faults showing up in the gravity, and we've modeled that in our 3D Victoria modeling project that you can see here, and again matching up quite well with the latest modeling of the magnetic bodies as well. So here's the two structures that I showed earlier. You can see the mines and prospects in the stars there. And really the question is, what are these regional transpressional northwest trending structures potentially a secondary control on mineralization along the north-south primary structures that are tapping the volcanics and bringing up the gold-bearing fluids? So maybe they're being localized by these other north-south and potentially northwest and potentially northeast structures. So moving over to the west now, looking in the stall zone, we've got our seismic lines. If we look at this line here, you can see again a very similar mineralization system as we see in the Bendigo zone, so deep crustal faults, the Moyston fault, being the western margin of the Stall zone, the Evoker fault mapping out the eastern margin, and we have all these faults within the zone, west dipping faults within the zone that are tapping down to the moisten, and again bringing up hydrothermal fluids, gold-bearing fluids to the surface. So interestingly enough, the moisten fault is tapping the very deeper crustal levels beneath the Bendigo zone. So presumably the fluids have moved up the moisten fault and then come off the moisten fault up into the upper crustal positions. And just for reference, St. Arnaud gold mine is located about there. So again, associated with these faults. And if we just have another look at further west in the Stall zone, we've got another seismic line through there, the AR1 line from 2009. There it is there. There's the Murray Basin cover and TMI magnetics underneath. You can see where Stall gold mine is in association to the line there. So the model for this region is the Stall corridor, which is the Moorabool metamorphic complex, and mineralization here is associated with Cambrian basalt domes that we can identify in the magnetics in the south and utilize the magnetics undercover as well. So just looking at the section here, there's our Moisten fault and Coonji faults, and they extend to the north beneath cover. So if we strip away the cover and look at the TMI image, you can make out where it sort of is heading, but it's a bit hard to continue that further north there, I think. Again, looking at the magnetics with the basin stripped away here. If we apply some filtering to that data, I think it makes it a lot clearer and easier to trace where these faults go. So there's Stall gold mine and the Vars Irvine prospect, which is looking really good at the moment. And using the magnetics, we can map out the boundaries of the Stall corridor, the Moorabool metamorphic complex, fairly well. And interestingly enough, there's, in the magnetics, I think there's a whole bunch of interesting looking features, potentially mapping out basalt domes and the volcanics themselves. And so just finally, we can utilize all of these data sets and bring in all the mapping, the drilling, the geophysics, interpretation, modeling, and use that as a framework to build these 3D models that are really useful for understanding the bigger picture and the regional mineral systems in Victoria and how they relate to specific areas. So finally, I guess, we've heard of the golden triangle, but maybe we should be thinking more about some sort of deformed golden rectangle, or in this case, red rectangle. Thank you.